And welcome to today's lesson. I'm Miss Williams. Today, we will explore the question, how does the night sky change throughout a year? Are you ready? Grab your pencil and your science journal, and let's get started. Have you ever looked for constellations in the night sky? What time of year was it? What constellations did you see? I like to look up at the sky in December and find Orion. But when I look for the same constellation in July, it isn't there. Last time we gathered data about when constellations are visible in the sky. Why do you think some stars are only visible during certain months of the year? Do you think the stars could be moving? Or maybe Earth points in a different direction at different times of the year? Today, we will gather more evidence to explain why some stars are visible every night and other stars' visibility changes with the seasons. Let's use our current knowledge of the Earth, Sun, Moon, star system to investigate. We see stars at night, right? But why do we see stars only at night? Do you think that during the daytime, the sun makes it too bright for us to see other stars? That's right. During the daytime, the sunlight scatters throughout the atmosphere, which makes the sky bright. The stars are overhead during the daytime, but the bright sky prevents us from seeing them. How interesting. How can we use the Earth View student model to explain why we see stars at night? Well, the stars are on the walls here, right? The Earth student would need to face away from the sun to see those stars at nighttime. So the Earth needs to be between the sun and other stars. When the Earth student's back is to the sun, the student would be able to see stars on the walls. How can we use our model to explain why we see different stars at different times of the year? What if we keep the stars in the same locations on the wall and have the Earth student move? If Earth orbits the sun, then the part of Earth experiencing nighttime would face different directions in space throughout its orbit of the sun. Let's model Earth's orbit to see how it affects the visibility of constellations at different times of the year. How can we update the Earth View student model so the Earth student can see different constellations at different times of the year? If the Earth student is orbiting the sun, we could place different constellations around the room so the Earth student sees different constellations at night while orbiting the sun. But wait, how long does it take Earth to orbit the sun? Well, when we observed the star maps for each month in a year, we saw that the constellations visible in the sky were a little bit different each month. Sometimes the constellations were in different places in the sky than they were the month before, and sometimes they stopped being visible at all. However, when we looked at the star maps for January 2017 and January 2018, we saw the same constellations in the same places. So what does that information tell us? We can conclude that Earth was facing the same direction in space at nighttime during January of both years, because the constellation pattern was the same. The pattern repeats itself every year. So if the pattern repeats itself every year, then Earth must complete one orbit around the sun in 1 year. How can we label the room so that Earth's orbit represents a year? Maybe we can mark different sections of the room with the months of the year to indicate where Earth should be when certain constellations are visible. Earth should orbit in the order of the months of the year, right? So now we have the months of the year. Let's add the constellations. How do we know where to place each constellation? We can use our class data table to determine where to place the constellations. Let's start with Canis Major. Let's look at our data table. In which months was Canis Major visible? It was visible in January, February, March, November, and December. Those are winter months, right? So the Earth student must be facing the winter months for Canis Major to be visible. Nice work. Let's use our data table to determine which constellations are visible during spring months. Do you see any constellations that are visible during spring months but not year-round? I think Leo, Virgo, and Hercules would work. Let's add them to our model. So during the spring, the Earth student would be able to see Leo, Virgo, and Hercules in the night sky. Nice job. I used our star chart to add Gemini, Cygnus, and Orion to our model. But hey, what about Ursa Major and Ursa Minor? Where do we place Ursa Minor in our model? We put Ursa Minor on the ceiling because it appears not to move as Earth rotates. Ursa Minor is above Earth's North Pole, right? What do we know about Ursa Minor's visibility throughout a year? It's visible all year long. So from our location, we can see it at night during every month of the year. How interesting. So where can we add Ursa Minor and Ursa Major on this model? Do you think we can add them to the ceiling? That's a great idea. How can the Earth student see constellations on the opposite side of the classroom? Well, the Earth student would have to move to different areas of the room to see the different constellations. In other words, the Earth student would need to orbit the sun to see different constellations at different times of year. But remember, the Earth student needs to face toward the wall and away from the sun to see the stars in the night sky. So, what does this model show us? This model shows that our view from Earth at night changes throughout the year. Let's revisit our claim and evidence. Based on our new understanding from the full class model, we can evaluate our evidence and describe our reasoning for how our evidence supports our claim. We claimed that constellations are in different positions each month, and most constellations are visible from Earth for only part of the year. The pattern of constellations repeats every year. Your task for the last lesson was to list the evidence that supports the claim. What did you write? For our evidence, we can say that we can see which constellations are visible each month by using the star maps in our class data table. But what about our reasoning? How can we justify why this evidence supports our claim? Well, we learned that as Earth orbits the sun, it faces a different direction in space at night at different times of the year. So different stars are visible at different times of the year. Nice work. Let's add our new learning to our anchor model and anchor chart. We learned that Earth orbits the sun. The solid arrows represent orbit. We can also add stars to our anchor model. Great job. One of your tasks at the end of this lesson will be to update the anchor model. Now let's update our anchor chart. Wow, look at how long our anchor chart is. We have learned so much. Let's look closely at our section called stars. We learned that the visibility of stars changes as Earth orbits the sun once per year. Your second task for today will be to update the anchor chart. We've learned so much about Earth and space views of celestial objects. But Earth isn't the only planet in our solar system, is it? Based on our model of the Earth, Sun, Moon, Star system, do you think the sky will look different on other planets in our solar system? That's a great question. Now I wonder, how might the sun and stars appear differently on Mars? I have a photograph to show you that could help answer this question. This is a photograph of a sunset on Mars. What do you notice? I see the sun setting over the horizon, similar to what we see on Earth. But the sun looks much smaller than it does from Earth. Do you agree? Because Mars is relatively close to Earth, humans have sent rovers, robots that can move around the surface of a planet, to Mars to collect data. The Mars rover Spirit took this photograph in 2005. If Mars is another planet orbiting the sun, what do you think we could see in the sky from Mars? Well, we know from this photograph, we can see the sun from Mars. Maybe you wonder, can you see stars at night? Can you see Earth? Does Mars have a moon? What do you think? I have had so much fun exploring patterns in the sky with you. Do you look at the sky differently now? I know I do. Let's review your tasks for today. First, update the anchor model. Second, fill in the blanks to update the anchor chart.